In this lesson, I'll give you an overview of the Connectivity and Remote Access chapter. In this chapter, you'll learn how to develop apps that can connect to other devices and networks. On the developer's website, in the API Guide section, there are pages covering Bluetooth, NFC, or Near-Field Communications, Wi-Fi Direct, USB, Universal Serial Bus, and SIP, Session Internet Protocol. But let's take a quick look at each of these. Bluetooth is a wireless technology for exchanging data over short distances in the range of 5 to 30 meters. Bluetooth uses short wavelength radio transmissions in the 2400 through 2480 megahertz range. Android Bluetooth APIs allow a device to wirelessly exchange data with other Bluetooth devices using either point-to-point or multi-point connections. NFC, or Near-Field Communications, is a wireless technology for exchanging data over very short distances in the range of 4 centimeters or less. NFC operates at a frequency of 13.56 megahertz, a license-free allocation in the high-frequency portion of the radio spectrum. NFC allows you to share small blocks of data between an NFC tag and an Android device, or between two Android devices. Wi-Fi Direct is a wireless technology for exchanging data over distances in the range of tens of meters, depending on the devices. Wi-Fi operates at a frequency in the range of 2.4 gigahertz. Wi-Fi Direct allows Android 4.0, that's API level 14, or later devices with the appropriate hardware to connect directly to each other via Wi-Fi without an intermediate access point. USB, or Universal Serial Bus, is a wired and wireless technology for exchanging data over distances in the range of tens of meters, depending on the devices. Wireless USB operates at a frequency in the range of 3 to 10 gigahertz. Android supports a variety of USB peripherals and Android USB accessories, that's hardware that implements the Android accessory protocol, through two modes: USB accessory and USB host, where the Android device can act either as the accessory or host device. SIP, or Session Internet Protocol, is a wireless technology that lets you add internet telephony features to your applications. These can include voice conferencing, video conferencing, and instant messaging. Now, that's our overview for the Connectivity and Remote Access chapter. Now let's move on to more detail and examples. In this lesson, you'll learn how to implement NFC, or Near-Field Communications, in your Android apps. NFC is a set of short-range wireless technologies. Usually a distance of 4 centimeters or less is needed to initiate a connection. NFC allows you to share small blocks of data between an NFC tag and an Android-powered device, or between two Android devices. Simple tags offer just read and write capabilities, sometimes with one-time programmable areas to make the card read-only. More complex tags offer math operations and have cryptographic hardware to authenticate access to a sector of the tag. The most sophisticated tags contain operating environments, allowing complex interactions with code executing on the tag. The data stored in a tag can also be written in a variety of formats, and many of the Android framework APIs are based around the standard called NDEF, or NFC Data Exchange Format. So, with that as a background, let's take a look at an NFC demo. In the API Demos worksheet, there's a group of 3 NFC demos. We're going to use the foreground dispatch demo in line 154. And notice that it has the Java file name of foreground dispatch. So in the API Demos app, let's click on NFC and foreground dispatch. And the display tells us to scan a tag. To do this, since we don't have NFC capability on my computer, I'll have to use my phone. First, I had to turn on NFC in my settings. And here's a screenshot of my settings display where I checked NFC. Here's a screenshot of the app screen after scanning a tag. It's telling me it discovered a tag with the intent details shown here. And we'll get into these in a moment. And before we look at the code, I'm going to show you how I created the tag that was scanned. The first thing you need is some tags, and one place to get these is Amazon.com. If you search on NFC tag, you'll see a list of results. I ordered the product shown here. Next, you need an app on your phone to program the tags. I downloaded the app shown here on Google Play to my phone, NFC Task Launcher. Their page has some good screenshots and a video explaining the app. What you do is program a tag to activate a list of functions you specify in the NFC Task Launcher app. And this is one of the screenshots from their Google Play page showing the screen to specify actions. After you've done that, you click on Save and Write, and then you place your phone on top of the tag, and the app programs it to take these specific actions. I programmed my phone to activate the Maps app. And this is a screenshot of my phone after the Maps app had been activated by the NFC tag. And now let's take a look at the code. In the NFC source folder, we'll open foreground dispatch. And let's expand this out to get a better look at the code. Line 36 declares our foreground dispatch activity. Lines 37 through 42 define a number of variables we'll be using below. Lines 44 through 73 define our onCreate method. Line 48 uses the setContentView method to create our screen display using the foreground dispatch layout. So let's take a look at that. There it is. Line 17 declares a text view, and it has an ID of text. And the text view is centered in the screen vertically and horizontally. So back in our source, line 49 retrieves the text view and assigns it to mText. Line 50 initializes the text telling the user to scan a tag. 52 gets an NFC adapter and sets it to the variable mAdapter. 57 and 58 create a pending intent that'll be delivered to this activity when a tag is scanned. The NFC stack will fill in the intent with the details of the tag. Line 58 contains details of the intent. And the flag activity single top means that if set, the activity won't be launched if it's already running at the top of the history stack. Line 61 creates an intent filter using the action ndef_discovered. 62 through 66 create a type using a / with any sequence of characters before or after that will match all MIME-based dispatches. Line 72 sets up a tech list for NFC tags. The tech entries refer to the qualified class name implementing the technology. For example, NFCF, as we're using here. And NFCF is a class that provides access to NFCF JIS 6319-4 properties and I/O operations on a tag. And JIS 6319-4 stands for Japanese Industrial Standard 6319-4. Lines 75 through 80 define the onResume method. 78 and 79 enable a foreground dispatch for the adapter using the intent, filters, and tech list. Lines 82 through 86 define the onNewIntent method that's invoked when the intent we registered for is received. And it's here that you do the work in your app in response to a given tag being scanned. Line 84 logs a message identifying the tag. Line 85 displays the intent on our screen. Let me bring that up. It's displaying this text. Lines 88 through 92 define the onPause method, and line 91 disables the foreground dispatch intent when the app is paused. That's our lesson on connectivity using NFC. It's a fun technology and relatively easy to implement. In this lesson, you'll learn how to use the connectivity and remote access documentation to guide you in developing these features for your apps. Going through the code details of all the connectivity and remote access methods is beyond the scope of this course. However, at this point in the course, you should be ready to venture out on your own in learning new Android capabilities. What I'll do in this lesson is highlight aspects of the documentation and samples that should help guide you through learning and using these capabilities yourself. Let's take a look at Bluetooth as an example. On the right-hand side of the page, there's a very useful summary of key aspects of the Bluetooth feature. First, a quick view of the feature. In this case, Android's Bluetooth APIs allow your application to perform wireless data transactions with other devices. Next, there's an overview of the contents of the document. And this is useful not only for gaining an understanding of what's on the web page, but also what's necessary to implement the Bluetooth feature. For example, permissions, setting up Bluetooth, finding devices, connecting devices, managing a connection, and working with profiles. Next is a summary of key classes, in this case Bluetooth adapter, device, socket, and server socket. And finally, a list of sample apps related to Bluetooth, in this case Bluetooth Chat and Bluetooth Health Device Profile. In tackling a new Android feature, I personally like to start by looking at a sample, for example, Bluetooth Chat. Let's go through a refresher of how to access these samples. We'll use the Android wizard. So in Eclipse, we click File, New, Other, Android Sample Project. Next, select your build target. In this case, I'm using Android 4.2.2. Click Next. And here's our Bluetooth Chat app. Highlight it. Click Finish. And we see it's been added to our workspace. Next, I like to use the various sections of the feature page to understand key elements of the code. For example, on the Bluetooth page, in the section Setting up Bluetooth, in Step 1, Get the Bluetooth adapter, there's a code fragment and an explanation of the classes and methods used. And Google has included some very handy links to classes and methods if you want to see more detailed information, for example, on the Bluetooth adapter. This is a class description with all the lower-level detail, including its methods and method parameters, for example, close profile proxy. Understanding how a code fragment fits into an app can sometimes be challenging when you're just seeing code all by itself, such as using the Bluetooth adapter. And this is where the sample apps are particularly useful. They put code in the context of an application so you can see how it fits into the bigger picture. In the connectivity section of the API guides, you have pages for Bluetooth, NFC, Wi-Fi Direct, USB, and SIP. And you should be able to use each of these in the manner we've just discussed. Dealing with remote access is slightly different. On the main connectivity page here, there's a link to a blog article, Android's HTTP clients. And this article gives some background and detailed information on remote access. And my guess is that Google will create an official HTTP web page like our other connectivity methods have their own page soon. At the end of this article, the HTTP URL connection class is recommended as the best choice going forward. On that page, there's detailed information about how to establish a connection over the internet, including some code samples. Now, one additional topic I'll mention, in addition to those that you'll find on the Android website, is that of JSON formatted data. On Wikipedia, there's a good article shown here on JSON, or JavaScript Object Notation. This is an increasingly popular format for transferring data between clients and servers across internet connections. If we click Data Types, we see that it's a human-readable format with special characters separating different types of fields. Back on the Android website, if you search on JSON, you'll see a list of useful references, JSON classes, objects, and methods that can be used to construct and parse JSON strings for communicating between client and server applications. For example, the JSON Reader class page includes details and sample code for parsing a JSON data stream. That's our lesson on connectivity and remote access documentation and samples. Our chapter on connectivity should give you a good foundation for creating apps that can interact with other devices, both up close and at a distance.